In this video, I'll be talking about path planning, what it actually is, and what the basic principles are that we need to know. So essentially, the goal of path planning is to move a robot from one pose to another pose within an environment. So it's at one position, we need to move it somewhere else with a unique pose, and which is position and orientation associated with it. And to be successful, generally what we want to do is do the following. We want to avoid collisions, so we won't want to run into things. We want to avoid getting stuck, so if we had a local minima area that we needed to get to here, but we were going this way and we got stuck in this spot here and couldn't make any further progress towards our target, that's called a local minima. And really we want to avoid wasting time. So we don't want to choose the worst possible route, so it takes us a whole lot longer, a whole lot more power and so on to actually get to the location that we want to go to. And we have a number of other issues associated with it as well. For example, how much do we actually know about the environment beforehand? Do we have a complete map, or do we know nothing whatsoever about it, or is it something in between? Do we have an old map maybe? Does a path actually exist? So we want to get from here to here, our current position to our target position, but is it actually possible? Is there a double brick wall in the way that's actually preventing us from doing so? Is a path maybe available some of the time, for example when a particular door is open, but not other times? Well, what if the environment changes during the execution? What if there's things moving, whether it be a person walking through, or a cat or a dog, or a door being opened or closed? All those things can affect us. And do our sensors allow us to detect everything? So are there things, for example, if we're using reflectance-based sensors or sensors using light, that don't reflect any light, and so our sensors don't actually detect them? Or are we using our ultrasonic sensors where if we put a particular angle, we won't get any reflection back? What about other things like uneven paths where odometry becomes an issue? Or what about stairs and things like that? There's all sorts of path planning issues that can crop up and can cause our path planning to actually fail. There's also lots of solutions to many of these problems, and it's actually an area of ongoing research. Here's a few of the solutions, things like potential fields, A star and D star, vector field histograms, dynamic window approaches, rapidly exploring random trees, Voronoi diagrams, evolutionary algorithms. But there's more, and these give us a number of different ways based on local navigation and global navigation for us to move from one point to another. The term local navigation we refer to when our robot's trying to navigate its way around, and it's doing that based on what it can see around it. And global navigation, in contrast, like our A star, gives us a complete map and maps everything out beforehand and tells us the best way to get to a particular location.